Hello everyone, welcome back to my channel. As you all know, this is Trutana graduating in Sri Venkateshwara College of Engineering, Bangalore, Department of ECE, Semester 3, and the subject is Computer Organization and Architecture. The topic is all about bus structure in computers. Let's come to the introduction part. Introduction to bus structures. The bus structure in computers is a communication system that transfer data between the components. It serves as a shared pathway that connects the CPU, memory, and input as well as the output devices. Understanding bus structures is essential for grasping how data flows within a computer system. Computer bus, a single bus, and a multi-bus is the types and the bus structures. And this is the single bus structure, what we are seeing in the picture. CPU, memory, and input device, and as well as the output device. What is a bus? A bus is a collection of wires through which data is transmitted. It can be thought of a highway for data transfer between different parts of a computer. Buses are categorized based on the function such as data buses, address buses, and control buses. There are several types of buses, three primary types, that is data buses, address buses, and the control buses. Data buses carry the actual data being transferred, while the address buses specify the location of the data, and the control buses manage the signals that control the operations of the computer's components. Let's see one by one in detail. Coming to the first, data buses. The data buses are responsible for transferring data between the CPU, memory, or input and output devices. The width of a data bus measured in bytes determines how much data can be transferred simultaneously. A wider data bus can improve all over system performance by allowing more data to be moved at once. This is motherboard bus structure. We can see the memory, graphic card, CPU, and the system bus structure, and then connected to the PCI slot. Address buses. Address buses are used to specify the memory addresses for data transfer. The size of the address bus determines the maximum amount of memory that can be addressed by the system. For example, a 32-byte address bus can address up to 4 GB of memory. As well as we know the components like CPU and memory, input and output. There are many registers available in the CPU, and the data bus, address bus, and then control bus is connected. Control buses. Control buses send control signals to manage the operations of various components in a computer. These signals detect when data is sent, received, and processed within the system. A well-functioning control bus is critical for the synchronization of the computer's operation. This is hardwired with the unit, picture, components, and the blocks. And coming to the bus architecture. Bus architecture defines how buses are organized and how they interact with other components. Common architectures include single bus, multiple bus, and crossbar switch configurations. Each architecture has its advantages and disadvantages in terms of performance and complexity. This is the processor, memory, and then followed by the control line, address line, and the data line. Input device 1, input device n. Number of input devices can be given in this system. This is the structure of bus. And coming to the advantages of bus structures, the advantages are bus structures simplify the design of computer systems by reducing the number of connections needed. It reduces the connections that we are needed to the simple form. They facilitate communication among multiple devices, allowing for efficient data transfer. Cost effectiveness is enhanced due to fewer physical connections and simplified routing. Disadvantages of bus structures. What are the disadvantages of bus structures? The bus structure can become bottlenecks as more devices are added to the system. Increased contention for bus access can lead to slower overall performance. Limitations on bus bandwidth can restrict the speed at which data can be transmitted. Yet the bus structure's unit objectives describe the primary types of buses and define interrupt, IRQ, and input as well as output addresses, DMB, and base memory addresses. And the next point is describe PCI and PCIe buses and PCI and non-PCI video standards. Coming to the future trends in bus structures, emerging technologies are leading to faster and more efficient bus systems such as PCI and USB 4.0. Future buses may incorporate features like increased bandwidth and reduced latency. The trend towards integrated circuits may also redefine traditional buses structures in computing. Thank you. If you like my video, please like, share and subscribe.